more. I'd like to welcome you to our World Majlis.
اليوم نحن في أشد الحاجة إلى الحوار فيما بيننا. نحتاج إلى التواصل والتعاون في واحد من أكثر تقاليد الإمارات تقديراً، المجلس. المجلس العالمي هو ملتقى للآراء والأفكار المتنوعة، هو منتدى للنقاش والاستكشاف والفهم، للاتفاق والاختلاف، هو مساحة للاحتفال بالأفكار، أفكار تطلق العنان لإمكانات الأفراد والمجتمعات حول العالم، لتصميم التقنيات التي تفيد البشرية، لخلق كوكب جميل ليس ليعيش فقط بل ليزدهر، ومن أجل بناء مجتمعات تتخيل وتصمم معاً غداً أكثر إشراقاً. المجلس العالمي، حوارات لغد أفضل. More than ever, today's world needs us to talk to each other, to communicate and collaborate. In one of the UAE's most cherished traditions, the Majlis. The World Majlis is an open space where diverse voices come together to discuss, to explore and understand, to agree and to disagree. A space to celebrate ideas. Ideas for unlocking the potential of people around the world. For designing technologies that benefit everyone. For creating a planet that not only survives but thrives. And for building communities that together imagine and design a brighter tomorrow. World Majlis. Conversations for a better future.
Good evening, everyone. My name is Rohan Roberts, and I'm delighted to welcome you to the first virtual Expo 2020 World Majlis. As many of you are probably already aware, the World Majlis is Expo 2020's signature platform for connecting minds and encouraging conversations between thought leaders, visionaries, and change makers. The objective of the World Majlis is to generate new perspectives and incubate meaningful connections between people. Tonight, from the Expo 2020 Dubai site, we are connecting across multiple continents to talk about space and the cosmic perspective. We have with us an incredible lineup of participants from around the world. I'd like to take a few moments to briefly introduce them. Joining us from the UK is Lord Martin Rees, who is the UK's Astronomer Royal. He's based at Cambridge University, where he's a fellow and former master of Trinity College. Next, we have Dr. Steve Nerum, who is the Associate Director of the Colorado Center for Astrodynamics Research at the University of Colorado in Boulder. Joining us from Sweden is Cecilia Hertz, the founder and CEO of Umbilical Design, an innovation consultancy organization with over 15 years experience in space technology transfer. All the way from France, we have Professor Chris Welch, who is head of the Space Payloads Laboratory and director of the MSc in Space Studies at the International Space University in Strasbourg. We also have two university students joining us. Ahlam Al-Qasim is currently an astrophysics PhD candidate at UCL's Malad Space Science Laboratory in the UK, and Noura Al-Said is a PhD candidate at the University of Colorado in Boulder, majoring in astrophysics and planetary science. And our last but not least participant is Umran Sharaf, who is the project director for the Emirates Mars mission. And I'd like to invite Umran to say a few words to set the stage for our conversation this evening. Over to you, Umran.
Thank you, Rohan, and thank you everyone for being here today and for giving us the opportunity to discuss space and the future of the space for humanity, and also how UAE is taking this sector and using it for sustainable development. 2020 is a very important year for us, for the UAE. It witnessed the launch of the Arab world's and UAE's first interplanetary mission, the Hope probe. And 2021 is even more important for us because it will witness the arrival of Hope probe to Mars in February 2021. But also on the 2nd of December 2021, it's going to be the 50th anniversary of the establishment of the UAE, which was one of the key goals and messages behind this mission, was to send a message through this mission to the Emirati youth, but also Arab youth. The thing about this mission, the way that the UAE took space different than other countries, it actually wanted to create impact through space. So the main objective for the UAE government was not to reach Mars. It was to create impact. It was to use it as a tool to encourage Emirati youth to go into sciences and technology, to see drastic and quick changes and shifts in the mindset of the Emirati youth, to see a disruptive change in the academic sector, industrial sector, and also in the economic sector. So it's about the future of the UAE. It's about the future of our economy. It's about the future of addressing our national challenges. But also it's about sending a very strong message to the Arab youth through this mission, is that if the UAE, a young nation, is able to reach Mars in less than 50 years, then you can do much more. A country like the UAE, which has more than 200 nationalities living over here, who contributed to building this nation and helped us reach where we are today. It's about coexistence and accepting differences. It's about looking at things from a different perspective. It's about serving humanity. And that's one nice thing about space, is that we all have one identity. We are citizens of this planet. We're citizens of Earth. We're humans. So through this mission, the UAE want to send that message to the Arab youth and inspire them to actually think about how this region, more than 800 years ago, used to be a generator of knowledge, in which scientists from different backgrounds lived in this region, coexisted, and helped in building this region. The moment that we stopped generating knowledge, the moment that we stopped accepting differences as a region, we start moving backwards. So the UAE through space wants to change that mindset and wants to send a very strong message to the Arab youth that you can do much more given your history and giving the skills and the potential that you have.
Great. Thank you, Omran, for setting the stage. Before we start the conversations for this World Majlis, I'd like to remind our participants just a few housekeeping rules, and also for the viewers watching at home. So this conversation will run for 60 minutes, and then we'll open it up to the observers for Q&A. It's important that, like any true conversation, we look at this more as a conversational interaction and less of an interview style setting. So please don't wait for me to necessarily ask you a question. If you feel you'd like to respond to something that the other participant has said, feel free to sort of raise your hand, and I'll direct the conversation over to you. And also, everyone watching at home, please feel free to use the Q&A feature at the bottom of your screen and submit your questions to our participants, and we'll get to it towards the last 15 minutes of today's conversation. So let's get started with this latest edition of the Expo 2020 World Majlis. The focus is on giant leaps for humankind. What happens when we take a cosmic perspective to life on Earth? Now, life on Earth is profoundly connected with the rest of the universe. If we took a physics perspective, then we are connected to all matter in the universe, in that we're made of similar atoms. If you took a chemistry perspective, then we are related chemically to all life on Earth, that is DNA based. And biologically, we're related to our fellow human beings in that we all share 23 pairs of chromosomes. So in many ways, the future of humanity is connected with space exploration, and taking a cosmic perspective will be even more important in the years to come, primarily because ours may be the first generation to actually witness a human presence on an alien planet, on another planet, most likely Mars. And taking a scientific perspective as we move forward will be vital. And this will have an impact not just on science, but on all aspects of human culture and human society. So before I ask the participants to share their views on how they understand what the cosmic perspective is and why it's important, I'd like to share with the viewers at home the story of Voyager. I'm sure the participants are well aware of Voyager, but just for the listeners at home, Voyager was the space probe that was launched by NASA in 1977, and its mission was to explore the gas giants, and that's what it did. It took off from Earth and used the gravity of Mars to slingshot itself towards Jupiter, and it sent back astonishing pictures of Jupiter and its moons. And then it propelled itself towards Saturn and took spectacular images of the rings of Saturn and the moons of Saturn. And then its mission was complete, and it was all set to drift off into deep space and leave our solar system. But it was the genius of Carl Sagan, that beloved cosmologist and author, who suggested to mission control commanders at NASA to turn the cameras of Voyager around and take a picture of Earth from 6 billion kilometers away. Now, it wasn't immediately obvious why we would take that picture, because Earth would be practically invisible. But to their credit, NASA did decide to take that image, and Voyager beamed back all that data back to Earth using radio waves. And back here on Earth, we processed the image, and we discovered it had 500,000 pixels of mostly nothing, because space is huge and mostly empty. But Earth was visible in that image. Out of 500,000 pixels, Earth was just half a pixel. And that image is famously known as the pale blue dot. And Carl Sagan has written a beautiful response to when he first saw the image of the pale blue dot. And in it, he reminds us of how fragile and beautiful our planet is, and how important it is to nurture and cherish all life on our planet, especially given how we're surrounded by this enveloping darkness. So to me, whenever I contemplate the cosmic perspective, I'm reminded of this image, and it helps me zoom out and look at the big picture and take the long view. But let's hear from our participants. Let's start with Martin Rees. Martin, what is the cosmic perspective, and why is it important?
Well, I think, as you've just said, it's very, very important that we should see our Earth in a cosmic perspective. And the two most iconic pictures ever taken from space are probably the picture taken by Ed Anders from the Apollo program orbiting the moon, where he saw the Earth, and of course the pale blue dot. And these have shown us how fragile the Earth is, and how we need to think of it in a cooperation. And of course, in the middle of the pandemic COVID-19, we're more aware than ever of the need for the whole world to deal with a common predicament. But I think we've learned the importance of space flight, because not only does it give us perspective on the Earth, but of course, as we know, we depend on space every day for sat-nav, for communications, and for monitoring the environment, climate, etc. So it's terribly important that we should pursue space. And can I just say, speaking from England, that I wish you a safe landing on Mars, I guess just a few months from now. That'll be a real pioneering effort to land on Mars. And of course, as you say, that's going to be a precursor to perhaps landing people on Mars a few decades from now. And of course, the question everyone asks is, will humans be a species that is now alone in the galaxy and will spread out? Or are there intelligences elsewhere in the universe? It's fascinating either way. Either we are unique, or the universe is far more interesting than we imagine. Either way, it's fascinating. But space gives us a perspective, and we also know that we are linked to the stars in a very intimate way, because all the atoms in our body, every atom of carbon, oxygen, etc., was forged in a star far away in the Milky Way, which lived and died billions of years ago. And then it went into a gas which condensed into the sun and the planets. So we are literally the ashes of long dead stars. And so we have a more intimate relation to the cosmos than was ever imagined even by the astrologers.
Wonderful. Would anyone else like to share their thoughts on the cosmic perspective? Please feel free to chime in. It's not an interview. I know, was it Alam, you were saying you were moved by the pale blue dot as well, and by Carl Sagan's words the last time we spoke.
Yeah, so I think I'll add to that by saying the pale blue dot image has a very special place in my heart, because before actually finding out about this image, I remember having a very similar experience, probably to Carl Sagan, when I saw an X-ray image from one of my science professors of galaxies outside the Milky Way. And I was sitting at his desk and he pointed at this dot on the image and said, "That's another galaxy out there." And it blew my mind. Like, how can an entire galaxy, things that encompass the Milky Way, things that encompass objects like asteroids and comets and the solar system and star systems, so many of them exist and we can actually see them. And it's as simple as, a dot on an image. And that dot encompasses so much detail and complexity. And that for me was really when I fell in love with space, and I felt like I wanted to go deeper and I wanted to find out more about all these other worlds out there. So just gaining that perspective from Earth into a dot of another galaxy out there, just seeing Voyager's image of our pale blue dot, just makes it feel like we ourselves are part of this vast universe, and we have so much to contribute as well. And all our history is just in this condensed pale blue dot, as Carl Sagan put it. So it has a very special place in my heart, and always reminds me that, as minuscule as our problems, or as big as our problems seem on Earth, just reminding yourself that you're part of this vast universe, and that you're part of, as Martin Rees said, that we're made of stars, we're made of the ashes of stars from long ago. Just having this very intimate relationship with space really, really humbles you. And I think that for me is where my cosmic perspective comes into my daily life.
Wonderful. Would anyone else like to share how the cosmic perspective? Please, Steve,
I can say
go
a few
ahead.
words.
Yeah, please,
Well,
Steve.
I
Go ahead, Steve.
I come at this from the perspective of a scientist who studies sea level change with satellites. So we've been studying the oceans with satellites for 30 years, measuring the height of the sea surface, and of course, watching how it's changed over time. And so when I think of the perspective from space, I think of the scientific perspective, in that we can't really figure out what is all the things that are causing the sea level to rise without having the global perspective. If we just look at one place or even a dozen places on Earth, we would never be able to decipher the contributions of ice sheets and warming oceans and things like that. And so we critically depend on this global view that the satellites provide. But then I think also in my work, I do a lot of communication with the public and the media on these observations. And I think when we show a map of how much sea level's changed around the world over the last 30 years, it really kind of shows how none of us kind of live independently on this Earth. We're all connected. And the oceans is one of the things that connects us. And so seeing a map and seeing where sea level's been rising faster than other places or other features like that, I think really gets people thinking. You know, if they're not scientists, they can look at that map, understand it, and really realize that that their impacts on the Earth all sum together through all the humans living on Earth can impact the oceans and also the Earth in general and the environment. So I think as a scientist, I see that space perspective as being scientifically useful, but also gives us a perspective that we can provide to the public.
Great. Cecilia, I saw you had your hand up.
Yeah, I was waving a little bit here. So
Yeah,
first
please,
of
go
all,
ahead.
of course, wonderful to be joining in today's discussion and hear all different perspectives. Do you hear me now? Oh, nu är det... Nej, tittar du? Internet unstable, precis. Ja, kan du se om du kan hämta den här? So,
Okay, go ahead, Cecilia.
sorry, seem to be... do you hear me again? We should check the technique here. Yeah, I was saying that it's super interesting to hear all the different perspectives. And I would like to add on that and share a little bit of my thoughts coming from working a lot with the astronauts and also in the space technology transfer. Several of the astronauts that I have met and worked with over the past 20 years say that they would like to see politicians and decision makers travel to space to understand the vulnerability of our planet and also experience that from space we see no borders. And we also need to remind ourselves that once upon a time, as we see it, there was only space. And now when we are having both space and Earth, we need to, in a higher extent, build an interaction that will be beneficial for planet Earth. When exploring new frontiers, we in parallel need to ensure a process to bring back knowledge and insights for the greater good of humanity. A person who addressed this was Dr. Sally Ride, the first American woman in space, who pointed out that although we have sent highly sophisticated spacecrafts to study other planets, we have not taken a similar interest in our own planet. And she and her team recommended to start mission to planet Earth. And this brings us to the importance of the cosmic perspective, as many people wonder how space is linked to sustainability. And a common perspective is that these two are far apart. But when thinking about the International Space Station and future habitation on Moon and Mars, they are totally closed systems, and everything as far as possible need to be recycled and reused. And astronauts, for example, consumes exactly the amount of energy, food, volume, water they need. So what if we could apply what I call the astronaut lifestyle in our innovation processes, especially when it comes to developing future cities for increased sustainability, both through space technology and behavior changes? It also inspires to a new mindset. It brings a new perspective and inspires to be urban astronauts, what I call the urbonauts. So that's just to give a little bit of first of my thoughts and share with you from that perspective.
Yeah, I like how you suggested that we should send politicians out to space as well. I often wonder if politicians had a picture of the pale blue dot on their office wall, would that motivate them to take a long-term view instead of just a 5-year plan or a 10-year plan? Chris, I know you write, you're a photographer and you dabble in poetry as well. What would it be like to send artists and poets to space? How would they contribute to taking a cosmic perspective, and how would it influence how we view our planet?
Well, I think that would be an excellent step forward. There have been very few artistic endeavors in space so far. There's a phenomenon known as the overview effect. which is when somebody who is in spaces, normally close to space, is looking back at the Earth and they see it as a whole planet without national borders. And sometimes they feel a sense of sort of togethership with the whole of humanity. But of course, the people we've sent so far have not been as expressive as some others. And so to send an artist, to send a poet, to somebody who can communicate that in, say, non-verbal ways, I think would be extremely useful. I'm very committed to the idea of the democratization of space, of more people traveling into space. So far, predominantly it's been scientists and engineers for reasons which are well understood. But I think if we're to generate this cosmic perspective in more people need to see the Earth from space. I think that will reduce our tendency to be very self-centered, to look at ourselves, our immediate group. We have a tendency to behave in tribal sort of ways, when really our tribe should be, the whole human race.
Great. Martin, you've had a long and distinguished career in cosmology and astrophysics, and you've published over 500 research papers. What do you think would be the most interesting thing to share with the listeners out there who may not be as well versed with cosmology and space exploration as you are? What are a few things that would really blow someone's mind or impress them about the mysteries of space?
Yes. Well, first, the sheer scale, that there are 100 billion stars in our galaxy, 100 billion galaxies that can be seen with a big telescope. But what I think is the most important is that we now know that the stars we see in the sky are not just points of light. They're all like the sun. And we've learned in the last 10 years that most of them are orbited by a retinue of planets, just like the sun is orbited by the Earth and the other familiar planets. So we know now that almost certainly there are millions or even a billion planets rather like the Earth, the same size as the Earth, where water could exist on their surface, orbiting around stars in our galaxy. And this raises, of course, the big question: is there life on any of those? And sadly, we don't yet know, because we understand how life has evolved on this planet over 4 billion years, from the first simple life to the marvelous biosphere of which we're a part. But we don't understand yet what made the transition from complex chemistry to the first metabolizing, reproducing entities we call alive. We don't understand that. It could be a rare fluke, in which case our Earth would be unique cosmically, not just in our solar system, as the abode of life. But if it turns out that life would originate and start evolving on any planet like the Earth, then we've learned in the last 10 years the amazing realization that there could be millions of places in our Milky Way where that has happened. And of course, we have no idea what sort of creatures could exist out there. Even if simple life is common, then intelligent life might be rare. And as you know, there are some searches being made for it. But I think the important point is that we will know within 10 or 20 years whether any of those planets has a biosphere, because they're very faint. Because if you look for a planet around another star, it's like looking for a firefly next to a searchlight. The star is not very bright anyway, and the planet is close to it in the sky and much, much, much fainter. So to actually analyze the light from the planet is a big challenge. It will wait for the next generation of very big telescopes. And one is being built by Europeans, 39 meters across in Chile, and that'll be able to gather enough light from one of these planets around a nearby star to see if it's got chlorophyll and ozone and oxygen in it, and get some clues to whether there might be some vegetation. And that'll be really, really exciting. It won't tell us whether there's intelligent life, that's separate, but to know whether life has emerged in other places will be fascinating. And we know that within 10 or 20 years. And of course, we might know in our solar system. Venus, there's been a lot of fuss about recently. I'm not holding my breath. I don't have much hope that there's life there, but we should look for it. But under the ice of Europa, which is a moon of Jupiter, or Enceladus, a moon of Saturn, there could be something swimming. And if we could detect that, that would be fascinating, but it would have a momentous implication, because if we could discover that life had originated at a second place in our solar system independently, then that would say it couldn't be a rare accident. If it happened twice within one planetary system, it must have happened in a billion places in the galaxy. And so finding any evidence for life elsewhere in our solar system is important in its own right, but also because it makes the whole night sky far more interesting.
Wonderful. Omran, you've done a lot of work with satellites, Arabsat-1, Arabsat-2. How does taking a cosmic perspective have an impact on your day-to-day work with satellites, or now with the Mars mission? Perhaps you could share a few thoughts.
So it's all linked at the end of the day. Yes, as I mentioned, I worked on DubaiSat-1, DubaiSat-2, KhalifaSat, and other space programs that we have at the center, additional to the Emirates Mars mission, which just I would like to highlight that it's an orbiter. It's not going to land on Mars. It's going to orbit Mars. It's going to study the Martian atmosphere. So for us, it's very important, because at the end of the day, I mean, the missions that we worked on before were more Earth focused. This is the first mission that we work on that is deep space focused. It's about new knowledge. It's about understanding our solar system. It's about understanding another planet that scientists believe that more than 4 billion years ago might have been similar to Earth, and it started losing its atmosphere. It's turned into a dead planet. Better understanding that planet will definitely help us better understand Earth. So the nature of this project is very different than our Earth observation missions that we worked on before, which is more focused on problems on Earth. This gives us a much bigger, wider perspective. However, at the end of the day, whatever mission we work on, at the end of the day, it's about serving humanity. It's about preserving our planet. It's not about finding an alternative for our planet. We might find a different planet, we might go there, we might have humans living there. But again, I mean, our organic planet is Earth. That's our home. And that doesn't stop us from exploring other things. But then whatever we do in other planets, or whatever mission we have in space, it needs to serve the humanity at the end of the day. Whether by bringing new knowledge, whether by developing technology that will improve the quality of life or address challenges that we have on Earth, whether it's food security or water security. It's about developing more environmental friendly technologies that will again help humanity. So it's at the end of the day, when we look at it from a cosmic perspective, when we look at it from a deep space perspective, it comes back to serving humans. So the rationale doesn't change, and this is one thing also that maybe that humanity needs to think about, especially when it comes to outer space exploration, is that collaboration and science diplomacy and space diplomacy is very important when it comes to deep space missions, because the objective here is beyond us. It's much bigger than a nation or organization. The reason why the UAE was able to deliver this mission in 6 years, and compared to other nations, they usually take 10 to 12 years to deliver similar missions. And it's our first mission. It's because we collaborated. It's because we had our knowledge transfer partners at the University of Colorado Boulder. We worked with them. We didn't start from scratch. The direction from the government was to not start from scratch. Start where others ended, learn from others, build it, don't buy it. So it's a new model. And we didn't go and build our own rocket, or we didn't go and build our own deep space network. We utilized existing assets on Earth. So we're using the DSN network. We used MHI's H2A launcher to launch our spacecraft. We built the spacecraft with our knowledge transfer partners together, jointly. But this is why we were able to be efficient. This is why we were able to deliver the mission in a much shorter time period, and at the same time with a significantly lower budget. And that's because of international collaboration. And this is what I think, based on my experience, is something that the identity of such mission should be beyond just a specific nation. It needs to be inclusive of all other nations. It needs to be more collaborative, and which will expedite us even understanding what's happening around us.
Great, thank you. We haven't heard from Noura. Noura, would you like to share with us why, what made you decide to get into astrophysics?
Yeah, sure. I just want to say at first, I agree with all of the points that have been brought up about how the cosmic perspective is a very humbling one, and one that makes you see both the significance and insignificance of everything around you at the same time. And it's just a beautiful way to think about things in our lives. And for me personally, I was always interested in knowing more and answering questions about how things around me worked. And that's why I ended up in astrophysics, but really any topic in science fascinated me. And I think as a scientist, the cosmic perspective is very essential, because oftentimes while doing a PhD, you're bottlenecked into focusing on one topic. And this is especially true for me right now, where I'm just studying the water cycle on Mars. And so you can lose sense of the bigger picture. And oftentimes I need to remind myself to take a step back and see how my work fits into the bigger picture, not only on Mars, but for the science community, for understanding our solar system, understanding how extrasolar systems in our galaxy work. And actually, I find myself being inspired by ideas in other areas outside of astronomy that help my work. And this is something that Imran touched upon, that it is important to not just do things as an individual and reinvent the wheel, but to take inspiration from other people and learn lessons from different parts of the universe, because it provides parallels that once you zoom out, you're able to see. And so I personally think that anyone, regardless of whether they're in STEM or not, can benefit from having this perspective where you're able to draw from the experiences and from the lessons that the universe presents. And I think that that's very beautiful.
Great, thank you. Steve, did you have your hand raised a little earlier? I wasn't sure. Was there something you wanted to say, Steve?
I did not. No, I'm good.
Oh, okay. Okay, Alam, yeah, I see you have your hand up.
Yeah, I think I just wanted to add to what Noura said, and also to what Chris Welsh said. I think it's really important to incorporate different fields in the cosmic perspective. I personally love exploring the merge between artistic fields and science fields. And I think that really enhances my experience as a PhD student, trying to understand how that really fits into how we see ourselves and how we see space. It really gets you thinking outside the box. And it adds that creative element that scientists really need when exploring, a planet for the first time or trying to develop novel technologies. All of that doesn't come from textbooks. It comes from a lot of creative solutions. And it's really important to incorporate the arts into that as well, and getting perspectives outside of that. So I was actually really happy an astronaut a while back was one of the first to make a painting on the International Space Station. And seeing things like that always makes me happy, and always reminds me that I think also, as Noura said, sometimes we're always told to focus on one specific thing, which happens a lot during a PhD, but it's always good to take a step back and see all the different ways that people contribute to space and to the cosmic perspective.
Great. Chris Welch, would you like to share? Yeah, please go ahead. I see your hand up.
Yeah, I just wanted to come back on that, particularly as a lot of us taking part in this event today have PhDs and have experienced that requirement for at least a period of our life to have this kind of laser focus on one thing, to get really deep into it. And that will give you, if you like, a kind of microcosmic perspective sometimes. You're going down really, really deep, you start dreaming about the topic of your research, and you really get to know it at that scale. And then you can kind of zoom out and you can take in the macroscopic universe and you get a cosmic perspective that way. And you start to see how all the different pieces, you know, are connected. And on the one hand, as a scientist, that's deeply rewarding because part of science is looking for meaning, for order, for structure, for explanations. And yet at the same time, it speaks to something I think very fundamental in the human spirit, in a kind of a quest for beauty. And there is beauty in the universe in a variety of places. And so you can get it at both ends of the scale, at the microcosmic and the macrocosmic perspective.
Yeah. So let's perhaps maybe have a short conversation. Steve, yeah, you go for it. Yeah. Go ahead, Steve.
Okay. Well, I just wanted to connect back to the comments that were made about the space perspective and art and other viewpoints. Because I've had a kind of a unique experience here at the University of Colorado the past couple of years, where we started a new minor in space. We call it the Space Minor. And it's available to any undergraduate student on campus. So it doesn't matter if you're an art major or a history major or an English major, they're all invited to be part of the Space Minor. And we have classes in space and film. We have classes that incorporate acting into space themes. We have classes on music and space. And so I think other universities around the world should consider this because, you know, here at the University of Colorado, we're kind of known as a space university. And so, but a lot of the students felt left out of that endeavor. And so by creating the Space Minor now, everybody can participate and feel like not only like they're part of something, but also they can learn that there are jobs in the space business for them, doing art and music and films and other activities. Thanks.
Steve, tell us about the mirror you created in space.
I'm sorry, the what? Oh, the
mirror,
minor. That's what I was just talking about. The minor, the Space Minor.
Oh, the minor. Sorry.
That's
oh,
what I was talking about.
Sorry.
Was our
okay.
minor, which is you can Google the Space Minor at the University of Colorado and learn all about it. It's a great
all right,
great
awesome.
activity for the undergraduates. Thanks.
Yeah, and I'd like to come back on that because
yes.
where I work is National Space University is based around that entire concept. We are an interdisciplinary university. I'm a physicist engineer, but you know the students on my masters, you know, they will have lectures on space law and business and management and engineering and science, but art and ethics and you know intercultural aspects. So I think this is very much the way forward for the future, and you know, very much in the spirit of this gathering here this afternoon is to bring together diverse backgrounds and to engage them in dialogue.
Martin, you've written about ethics and space exploration. Would you like to come in at this point?
Yes. Well, first a bit about space mining. I think the economics may, in fact, not be very favourable for bringing stuff down to the Earth. But of course, if we are going to be assembling large structures on the moon or in space, then it may be sensible to get the materials from not the Earth, but a place with weaker gravity, etc., to assemble them. So I think that kind of space mining may make sense. But that leads to another question, really, about what is the role of human beings? Because perhaps I'm unpopular in this company in saying that I think the practical need for sending humans is getting weaker as robots get better and miniaturization gets better. We could now send a robot with AI that could explore the outer planets, happy to have a one-way ticket, and we could also imagine that large structures in space could be assembled by robotic fabricators, not people. So I think the reason why people will want to go into space, to the moon or to Mars, is simply as an adventure, a human urge to explore further. And if that's the case, I think it's going to be important that they should be prepared to accept risks, because one of the problems, in my view, with the American space program was that they launched people into the shuttle 135 times, and each of the, well, there were 2 failures out of 135 launches, and I think, if we remember, these were traumatic events in America. But that was a less than 2% failure rate. And I personally think that we could cut the cost very much if space was regarded as something that was very, very dangerous. And we launched the kind of people who are prepared to take a more than 2% risks. People who go hang gliding, round the world ballooning, things like that, and regard it as an adventure. And we should not use the word space tourism, because that implies routine. We should use the word space adventure and accept that we're sending the kind of people like test pilots or adventurers who are happy to take these risks. And my view is that they'll be the first people to be on Mars. And which country they come from, I don't know, I hope it'll be an international group, but they'll be the kind of people who are adventurers, and they may have a one-way ticket. They may be happy to end their lives there. And in fact, Mr. Elon Musk has said that he wants to die on Mars, but not on impact. And he's now 49 years old, so 40 years from now, it might be a reasonable goal for him to do this sort of thing. And I hope that there will be small groups of people living on Mars by the end of the century. But I'm afraid I don't believe it'll ever be a place with a large population. Here I disagree with Musk and with my late colleague Stephen Hawking, who talked about mass migration to Mars to avoid the Earth's problems. It's simple to deal with climate change compared to terraforming Mars. And I don't think millions of people are going to want to live on Mars any more than they want to live at the South Pole now, or would want to live in some capsules at the bottom of the ocean. I just don't think people want to go. And I think we should leave it to adventurers and to robots. But cheer them on.
Great.
May I respond to that, please?
Yeah,
Hi.
is that Noura? Yeah, please, Noura, go ahead.
Yes. Yeah, I 100% agree that it's getting more and more difficult to argue for human exploration as our robotics get better and better at what they do. But there is certainly an element that having a human explorer can bring that I think our technology is leagues and leagues far behind, and that is the human perspective in exploration allows for going off the cuff, you know, and not sticking to a specific code or a specific programming. And a great example of that is in Apollo 17, when Harrison Schmitt found a very off-color patch near the landing site of Apollo 17 and was able to discover this orange soil that was a remnant of an ancient fire fountain. So things like that, the human perspective, the perspective of like a well-trained geologist or a human explorer can really benefit in understanding, especially other terrestrial planets. But in any sort of exploration mission, I don't think that the robots and orbiters have reached a point where they can provide that unique perspective.
Great, thank you, Noura. Let's make a
Rohan,
slight detour and bring the conversation back down to Earth. And we're now in the midst of this pandemic. Scientists, Martin, I'll come to you in just a second. So we're now in the midst of this pandemic, and scientists have been warning us about a possibility of a coronavirus pandemic for years now, and we ignored the scientists at our peril. What are some of the other things that scientists are warning us, some existential threats from space that we would do well to heed the scientists? Martin, I know you've done work on quasars and gamma ray bursts.
Yes.
Perhaps you could share with the audience some existential threats to humanity from space.
Yes. I don't feel kept awake at night by anything coming from space. Asteroids are the most obvious ones, and we can calculate the risk. We know the number of asteroids, etc., and it's actually worth an investment to try and deflect ones that might come close. But the point about asteroids is that the risk now is no bigger than it was in the past. They're just coming in, not affected by humans. And we can calculate the risk, and it's rather small, really. But what scares me far more are the risks which are caused by human beings collectively. And there are really two classes, really. The risks caused by our collective heavier footprint on the planet. This is climate change, loss of biodiversity, and things of that kind, which are the consequence of a growing population or more demanding of energy resources. And we're very familiar with these rather unpleasant scenarios for the second half of the century, but also there's a risk of misuse of powerful technology, bio, cyber, and AI. We have pandemics, but there's a risk in future perhaps of engineered pandemics, things like that. And of course, pandemics are now worse in a sense because they can spread globally at the speed of an aircraft in a way they couldn't in the past. So we've got to, I think, worry about the collective impact of human beings on the planet, on the climate, and on causing mass extinctions. But also we've got to make sure that as technology gets more powerful, the stakes are so high that we've got to make sure that we can harness the benefits of it for providing food and energy for a growing population and minimizing the dangers of its misuse. And that's a big challenge, I think, for all governments to ensure that we can benefit from these technologies and avoid all the misuses of biotech, which are unethical or dangerous. It's a big challenge for governments.
Yeah, and I think that would connect well with what Cecilia does in terms of bringing innovation from space technology to human society here on Earth. Perhaps, Cecilia, you could share with us some space innovations that have practical applications here down on Earth.
Yeah, yes, indeed. I also want to a little bit connect back to what Omran says before, that space is actually to better understand Earth and to help humanity. So I think we need to really focus on this and see how this can bring so much good things to our planet. And it's not only about the space technologies, but it's also the inspiration from like the moon landing, also to think about the human explorer, which I think we really need to have the storytelling to bring it back to Earth. As mentioned also in the World Majlis brief, that how the moon landing was pushing the limits for what they thought was possible. And that's why I can't highly enough encourage the importance of pushing the limits now when it comes to achieve Agenda 2030, and also highlight the fact that everyone can contribute. So instead of what we hear a lot now, I think the negative or the impossible feeling, I think we should inspire to the I'm possible feeling. Also understand that each of us has the responsibility to maintain planet Earth for future generation. And when it comes to areas where we can also benefit from the cosmic perspective, I mean, the sustainability focus is high on the agenda in Sweden. Now also with Greta Thunberg paving the way on a global level, which also brings us to the important area of inspiring the young people, the coming generation, on how space can actually contribute to Agenda 2030. And we are in the beginning of a decade of action, and we will enlighten how space can be part of the solution. And this is also something we look forward to bring into the Space Week in the Swedish Pavilion, where I luckily are the program manager. So we will have a lot of things focusing on space for sustainability, which is a fundament. And I must add, I was so proud this morning when the Swedish topics were mentioned by Her Excellency Sara Al-Amiri in her keynote remarks. So the work we do range from everything from space for food production to maybe the more unexpected theme, space for wildlife, how space technology can stop poaching. And we will of course reflect upon the bridge between UAE and Sweden, as Emirati astronaut Hassan Mansouri traveled to the ISS in the same crew as our Swedish-American astronaut Jessica Meyer. And by involving the space sector, we have all technology we can wish for. So the focus will also be on leadership, creativity, and interdisciplinary global co-creation. And I think one of the best examples, also involving, of course, the human exploration, is the International Space Station, which also is nominated this year to the Nobel Peace Prize for 2020. And this will be announced, the winner of the Nobel Peace Prize, on Friday, this Friday. So the ISS also have the milestone this year of having 20th year of continuous human presence in space. And I think this is a beautiful example of global cooperation.
Great. I'd love to come back to that issue of collaboration when it comes to space exploration. But Steve, would you like to share with the listeners some of the practical applications of satellite technology? We know, it helps with communication and such, and you're doing a lot of work with sea level change. But perhaps you could enlighten the audience about why satellite technology is important for humanity.
Yeah, I think I touched on this earlier, but I really think it's that global perspective. Let me use an example of kind of looking at the weather versus climate change. The weather is kind of an everyday event, and climate change is really the long-term changes in the kind of the average weather. And so just looking at one location on Earth, it's very, very difficult for scientists to discern what is a long-term effect versus changes in the weather. And this is also true for the oceans and vegetation and a lot of other variables that we are trying to study. And so the satellites allow us to not just look at one location, but really almost every location on Earth. And many times we take with that perspective, we can kind of average out the variability, the daily variability, and reveal the longer term trends. And so without the satellites, we're really blind. We can't hope to understand this problem and solve the problem with just measurements on the ground. The satellites are crucial, and I really don't know how I would do my research without satellite measurements. And so it's that important.
Yeah. Chris, Omran, would you like to come in at this point? Anything that the others have said?
Well, it's very true that space applications have an incredibly wide range of uses. Environmental monitoring is obviously one of them. I think it comes into two ways, really. We're looking back at the Earth, and we have things that look back at the Earth, tell us about the environment, provide services for us, and we also look outward from the Earth across space. And we could do neither of these if we didn't have satellites in orbit. So whether it's measuring the background radiation left over from the Big Bang to establish where the universe maybe originated, or whether it's providing services for disaster relief on Earth. Both of those are practical applications of having a cosmic perspective, of thinking about space and how to use it for all our benefits.
Right, Ahlan, you had your hand raised.
Yeah, I just wanted to add that this is actually also really important, not on a global scale. So when you team up between agencies to launch a mission in space, but also on a student level, because a lot of undergraduate students launch CubeSats into space all the time. And that involves collaboration between many different institutes. And so this whole idea of collaboration really starts early on in any space field. So I, for example, work on such a CubeSat mission. It's funded by the UAE Space Agency, and we're hoping to launch it next year. And it's we have so many different teams involved, and navigating between different expertise, and really knowing how to benefit from what someone has to offer from an engineering perspective, from a science perspective, is really key. And also the managing side of it is huge. So I think with the HOPE probe is a really good example of that, and a very big collaboration between the UAE and the US, but also it happens on a student level, which is really nice to see. And those skills are transferable for hopefully when younger people rise up to more senior positions and run their own space missions.
Great. So we've, Cecilia mentioned the International Space Station. Omran spoke about the UAE's collaboration in space. There's CERN in Europe that involves scientists from dozens of different countries. Perhaps someone would like to share some more examples of how we collaborate in the space exploration field. Noura?
Yes.
Well, my example is more on the how we collaborate when we take that cosmic perspective, and then you said space exploration field. But it's a very good example on how looking at cosmic timescales, or the events that take place on larger timescales, larger than our own one human life cycle. And one example of that I really like to read about is the Svalbard seed vault, which is up in the North Pole in Svalbard, where they have a fail-safe seed storage for all the plant life that exists on Earth. And I think that that's a great example. Every country can submit a box of plant life and seeds for those plants that they wish to keep safe in case there is some kind of global disaster or need for it, even localized disasters or some other issues that those specific plants might face. And that's just one example where taking that cosmic perspective on a time scale, looking at time scales is very important. And there's no borders when you go into that seed storage. Every country has a rack that has its own seeds saved for the future of humanity.
Great, yeah, thank you. That's a really good example, Noura. Martin, you have your hand raised, and then we'll come to Omran after Martin.
Yes. Okay, well, just say the seed bank is a very nice example of a cooperation which benefits the entire world. And of course, when we think about climate change, then of course it needs international collaboration in the action. Otherwise, we will never achieve a stable climate. But of course, in science itself, I mean, science is the most international profession, really, because science is the one truly global culture. Protons and proteins are the same everywhere in the world, so science can straddle all boundaries of nationality and of faith more easily than most professions can. And so they find it easier to collaborate. But I think it's clear that more and more of the issues that the world cares about do require collaboration. Anything to do with the environment or the climate does, and also in a quite different arena, when we have the internet and these global companies. If we want to control them, we've got to have international agreements involving not just one government. So we've got to be international. And of course, in science itself, the collaboration is essential simply because these big projects are very expensive. And of course, no country can be expected to spend too much on skies research. And we do have in space and now on the ground, we have telescopes. There's a telescope called ALMA in Chile, which involves Europe, North America, and Japan, ground-based global collaboration. There'll be more like that. So I think we realize that science is going to become more and more collaborative. But just let me make one other point, that in space, it's not just big projects. As we heard, these shoebox-sized satellites, or even smaller ones, can be launched. You can launch 100 of them at a time, and each one can be done by a school or a small group. And so space launching of small satellites is becoming more routine. So space is becoming a more ubiquitous part of our lives, from the very small satellites to the huge projects.
Great, yeah, thank you, Martin. Omran, I thought I saw your hand up.
Yes, so what I would like to add to what was just mentioned also when it comes to applied research and space applications. So when we look at, for example, sciences in general, there is basically science for policy and there's policy for science. And they complement each other at the end of the day. And the space assets play a very big role when it comes to science for policy, especially the space assets that are orbiting Earth. And I think one of the things that we need to think about, especially when it comes to the space community and about going back to what Lord Martin just mentioned about the budgets and about the costs and the importance of collaboration and having space diplomacy being a big part of that, basically. On top of that is basically that building the rationale, because at the end of the day, governments will have to fund these projects. Government, whether it's done by the private sector or whether it's done by the government, but entities, at the end of the day, the funds usually come from the government. So the rationale is very important, and to have the public engage and understand the reasons behind it. So one of the challenges that most probably currently governments face and will face in the future is justifying the budgets for future missions. And international collaboration definitely plays a big role in helping and in reducing the cost and the burden on governments. But on top of that, there's one thing that that's not been maybe discussed a lot is how can we make the science that we've been doing deep space missions be used for science for policy. Understanding a planet like Mars, a dead planet, it's losing its atmosphere. I think as a scientific community, as a space community, we need to invest time and effort in bridging the gap and also using that information for decision makers when it comes to, for example, environmental policies that are related to Earth. I know there's a lot that needs to be done. There's a lot of information that needs to be gathered, but I think the future also of space exploration and the sustainability of it depends also on bridging those gaps and trying to expand beyond just space application or space assets around Earth to space missions, in deep space missions, and how this information that's providing us will help us set policies that will preserve our planet and help us on this planet. Whether we can even, for example, invest in technologies that will be used to put the first human on Mars for him to survive, or for her to survive there. How is that going to help us in addressing challenges on Earth when it comes to water and food and so on? So I think this is some kind of a dialogue that needs to happen. And I think that there's a shift that needs to happen in the discussions with regards to the engagement of the public, in which we have them even more engaged in these discussions. And we need to show them, as a space community and scientific community, those links. And I think that there's a lot of work needs to be done there.
Great, yeah, thank you. Steve, Chris, would you like to come in at this point? And a quick reminder to our listeners, please feel free to send in your questions. We'll be taking those questions in a few minutes. Chris, let's start with you, and then we'll go to Steve. And perhaps if there's time, we'll get to Cecilia as well. Chris, yeah, go for it.
Okay, I'd like to come back to some points raised earlier about raised by Martin about whether we should send humans into space or whether we should send robots into space. Because if things had been different, maybe we would we would all be meeting in person now, and I think we would all very much rather interact personally. This is a good way of having a discussion if we can't. But it seems to me the barriers are really at the moment the cost of getting into space and as Martin correctly identified, the risk. And if the cost of getting into space can be lowered significantly, then I think more people would at least maybe want to go maybe on a day trip to low Earth orbit, or maybe a short mission to the moon. We're in this intervening stage. In the past, only governments have been rich enough to afford to do things in space. So it's tended to be primarily for science and sometimes for security reasons. So I think if somebody like Elon Musk or maybe Jeff Bezos or maybe some new player can bring the cost of getting to space down, then it will be easier to go. And in the same way that we wouldn't want to send robots to Dubai to take part in a conference, we won't want to send robots to the moon if that's what we want to do. We will want to go and experience it directly ourselves. And I think that's that's part of it. The cosmic perspective is as much about sort of the human spirit as it is about sort of, so we say, scientific exploration.
Great. Steve, do you have any thoughts on the influence of science on public policy and government policy?
Oh, that's a big topic there. The especially here, especially in today's kind of political climate, it can sometimes get frustrating that the science is ignored, and that the messages that the data are telling us are ignored. I think that's why, at least in my research, I try to just focus on what the satellite data are telling us, and not try to get too personally involved in it, because I want the topic to be judged just from what the data are showing, because it's pretty clear what's going on. I also want to return to this idea of collaboration. Over my career, I've been involved with many missions that are joint between the U.S., meaning NASA, and other countries. And those collaborations are usually done because we're trying to share the cost of the mission with another country. But I think there's an added benefit there that, at least for me personally, is that I've learned so much about the cultures of other countries and their different perspectives. And really, when we present the research, it's now not just the U.S., but it's really a whole team of countries that are showing what is happening on the Earth. And so I think there's a value in collaborating on space missions, such as the collaboration between the University of Colorado and the UAE, that goes beyond just sharing the cost. There's something to be said for learning about other cultures, how they do science, how they approach these problems that we have in the world, and we shouldn't forget about that. Thanks.
Great, yeah. Thank you, Steve. So let's do a quick audience check. If there are any questions from the audience, it should appear up on the screen right now. And if not, then we'll come to Cecilia. Right. What is the best way to increase science literacy or cosmic thinking among the population. So how do we increase a general science awareness? So this is an educational question. Anyone with an educational background or strong opinions about how we educate the public?
Well, I'm prepared to leap into that since I work at the university. Well, partly, I think it starts right at.
Sorry, he's speaking.
Oh, sorry, who was it?
Yes.
I was speaking, Chris.
Yeah, please,
Yes,
Martin.
yes.
Was it you speaking? Go ahead.
No, him.
Oh,
Chris
Chris.
was speaking.
Chris, go for it. Sorry,
I have some comments also.
There's a delay.
Mm-hmm.
Okay, so sorry about that. Well, I think in a society, really, science education starts at the youngest ages. It starts in primary school, and that's the first stage. You have to get science in there so that it's accepted as a normal, everyday activity, and at the same time, you have to have very strong role models. So, for example, in a UAE, context. The UAE astronaut and the engineers working on the UAE space missions are all excellent role models for children, and that embeds it at an early age. And then once people have come out of education and they're in the general public, then you have to have an active and ongoing outreach campaign to explain the various issues in science. Obviously, I'm focused on the space ones, but we know that they apply across the board. And you have to have excellent science communicators, journalists and other people who work for organizations whose job it is to interpret and explain science to the general public. That's all.
Great. Who'd like to go next? Martin, would you like to complete your thoughts?
Yes. Just a comment, of course, young children, certainly in my country, are fascinated by two things, dinosaurs and space. And the trouble is that if the science teaching is uninspiring, then they lose that enthusiasm when they get to the teenage stage. So one has to build on those early enthusiasms to diversify into more practical sciences and to maintain the mystery and wonder. I think that's crucially important. But the other point is that we do need charismatic figures. We've mentioned Carl Sagan. We need people like that who will get through to the public. And that's important not just for education, but it's because politicians will only support scientific projects and space projects if they think the public is behind them. They won't support them just because a few experts say that. And so it's only if the public is enthusiastic that the politicians will allocate money for these projects. And so that's another reason why we need people like Carl Sagan.
Right. Cecilia, I know you've had your hand up for a while. Would you like to address this question, or shall we take another question? Go ahead, Cecilia.
I can quickly just comment on that. And of course, I agree with you all that we need to work with the small kids as they still have all their creativity, like full capacity. And so we need to see how we can have them keep it. And I think then we need also to add, be more communicative around what actually space brings down to Earth. I mean, give real examples like how much water consumption we could actually, I mean, for example, we have buildings with 90% less of water consumption by integrating space technology in the building. Is an example from NASA Ames sustainability base, where I visited and looked into how they have integrated a lot of space technologies to make a really sustainable building. So I think we need to be better on communicating actual benefits for the planet.
Great, thank you. Omran, did I see your hand raised? Did you want to address this?
I think everyone actually covered it, but yeah, just going back to how to get the public more engaged and increase the sort of the awareness of space. I think it's very important also going back to the point is making the public take ownership of the space missions that a nation or the world is taking. For example, the Apollo mission. It was a US mission, however, the whole humanity was actually following up that mission, and everyone's talking about it, and everyone's inspired by it. So everyone took ownership, regardless of which country they came from. And even the approach taken by the US was quite smart, in which they took the flag of all the nations to the moon, and they came back and they visited every single country, and they spoke to the leadership of that country about and briefed them about the mission. So having the public engaged, having them taking ownership of these things is very important. And that's where the role of the leadership plays also extremely important, in which they set the tone and sort of the priority for that mission. Obviously, there's national pride that's linked to it, but also, you know, the fact that it's challenging, the fact that it's mysterious, the fact that it's out there. All this, I think, inspires. But then, how to keep the momentum? And keeping the momentum, that's the difficult part. And maintaining that momentum for the next generation to take over and to actually still be inspired and actually is aware of that, of the mission. And to do that it's very important to show the benefits, to justify the benefits. And again, to simplify the science, simplify the language, to speak the language of the layman. So it's a combination of things that you have to do. It's not just targeting the young generation, but also the teachers, the students, the professors, the universities, and so on. So it happened at different scales, and also the politicians, and getting them involved and having them sort of more aware of the benefits of these missions. And this is going back to the point I mentioned earlier, is about bridging the gaps and showing how the work we do is actually serving policies, serving national interests, serving the public. And again, it's an ecosystem that is going to hopefully benefit to come back to more policies and support that will bring funds and resources to space missions and so on.
Maybe some.
Great, thank you, Imran. So we're now down to our last 5 minutes, and perhaps we'll go to our last question, which is essentially about the next big frontier for humanity. I mean, if you think about it, the technological level at which our world operates is simply extraordinary. We've got global positioning satellites in space. We've landed space probes on the surface of a comet. And we've got relandable rockets, and we're planning to go to Mars. So what is the next big frontier for humanity? And this is an open question. I don't know if we'll get a chance to come to this question by Sitora, but let's answer the question on the next big frontier for humanity when it comes to space exploration. Anyone would like to go first?
I'm sure I can maybe pitch in.
Jump in.
Let's start with Alan, and then we'll get to Martin. Alan, please.
I think when people think about the next big frontier, I don't know about you guys, but I think about Mars and whether we'll be able to get there. And I think that what gets us there is really what's going to set the momentum for future deep space explorations. Are we able to build a colony there? So I know, for example, the UAE has a 2117 mission to have a Mars colony in about 100 years from now. So I think aiming towards that, building the technology for that, having a very ambitious vision to look forward to, that really requires multiple generations of people to actually carry it through. The people alive right now won't be there to witness this come to fruition, but we're all collectively working towards it. So really, really going for the long-term vision that makes everyone feel like they can actually have a part in it. It's not some exclusive thing. I think that'll really drive the future of space exploration and the frontiers of space science.
Great, thank you, Alan. Yes, please, Martin, go ahead.
Yes, well, I agree with what's been said, but just one thing. I think one target would be that by 2068, which is nearly 50 years from now, we should have a picture of an Earth-like planet. And that's a resolved picture, which will be taken by a big telescope in space. And I mentioned that year because that will be the centenary anniversary of the famous Earthrise picture taken by Ed Anders, which had such a big influence on all of us who were alive in 1968. 2068 have a picture of an Earth-like planet around another star.
Great. Would anyone else like to come in at this point? We're coming to the end of our conversation. Perhaps we could show the question for Omran, and then we can end on that. Could we display the question for Omran that was up there? Was that your voice in the countdown that we heard in the Al Wasl video? If yes, how did that feel? Was it you?
So yeah, I was doing the countdown in Arabic for the Emirates Mars mission launch. And how did it feel? I was quite, happy, proud, but at the same time scared while doing the countdown. So it was a very important moment in which I was more focused on the numbers in front of me rather than watching the launch itself taking place, because the numbers were indicating what's happening and so on. And trying to keep an eye on the launch at the same time, the numbers was quite, an interesting experience. But yeah, it felt like a big responsibility. And at the same time, it's basically the work of the past 6 years being launched in front of you. And for the first time, the countdown in Arabic for that launch, for the first interplanetary mission sent by the Arab world. It was a nice moment.
Great, thank you. On that note, we've come to the end of this edition of the Expo 2020 World Majlis. I'd like to thank our participants for joining us today from different parts of the world. It was a wonderful conversation, enlightening and educational. Thank you for your knowledge and for your insight. And thank you for the audience listening from various parts of the world. Thank you for your questions as well. We'll end by making a connection with the next Expo 2020 World Majlis. And I'd like to mention a quote by Stephen Hawking. He once famously said, Earth, or rather the human race is just a chemical scum on the surface of a moderate-sized planet revolving around an average star in the suburbs of an ordinary galaxy. And David Deutsch, who is a quantum physicist, disagreed with that perspective. And he took the perspective that Earth is quite special. And he gives us the example of a cosmic cube, and he asks us to imagine dividing the entire universe into cubes the size of our solar system. So imagine each cube is 20 billion kilometers across. And he asks us to imagine, what would an average cube look like? In other words, what would a typical place in our universe look like? And most people would assume that a typical place in our universe would be teeming with stars and nebulas and galaxies and so on. But Deutsch reminds us that a typical average cube would be cold, dark, and empty. How cold? Your typical place in the universe would be just a fraction of a degree above absolute zero. How dark? So dark that if a supernova exploded and you were looking at it with your naked eye directly, you could wait forever and still not see the faintest glimmer of light. And how empty? A typical place in the universe would be far emptier than the best vacuums we can produce on our planet. And so in this cold, dark, and empty universe, Earth is a pretty special place. It's teeming with life. The biosphere that allows for life to exist a few kilometers above the surface and a few kilometers below. We see thousands and thousands of different species flourishing, birds, animals, plants, mammals, and so on. And so that connects, that reminds us that Earth is a pretty special place and is an unusual place in this cold, dark, and empty universe. And that ties in with the theme and topic of our next Expo 2020 World Majlis, which is biodiversity. And we'll talk about the complex web of nature, the interconnections between life on our planet, and why it's important to take a scientific perspective on protecting the biodiversity on our planet. And on that note, I'd like to thank our participants and our listeners for joining us. Take care, be safe, be well, and see you on October 19th at the next World Majlis. Thank you and goodbye.
Thank you so much to our World Majlis panel and to everyone who has contributed and watched today here in the studio, at home, in office, or anywhere else. This has been truly a global effort, and it has been a pleasure to be part of this first day of true Expo 2020 content and programming. There is so much more to come tomorrow, though, including the opportunity to hear from the incredible work that many of our participants are doing within the space industry. It's an amazing lineup from all over the world, and we cannot wait for you to learn more about that tomorrow. For now, we'd like to leave you with one final video, one which captures all the excitement of our pursuit of the dream of human flight. Thank you so much for joining us today.
Jetman being a Dubai-based product since 2014. We were so close to nailing human flight, and that's why we created Mission Human Flight together with the Expo 2020.
Taking off from the ground and landing back on the ground, filling the gaps and being a complete package. At the moment, we need aircraft to get us to a dropping altitude where we fly, and then a parachute to bring us to the ground. But this can take us to a point where we're autonomous and without any assistance from other vehicles.
We are thankful that Expo, they are supporting the project, and we can't wait to go further. You know, we have one goal, one dream, it's to be able to take off and land from the ground.
You can be a jetman in the future, just you need to follow the steps. In the beginning you have to be a skydiver, you need to have to free falling. Second thing is you have to be a pilot, you take the PPL course.
PPL is normally an 18-month program, but we only have 1 to 2 months to complete his PPL and all his exams. It's a big responsibility, and I can see that he doesn't take it lightly at all. He's very, very focused.
There's a lot of benefits to Ahmed through training for speed riding. One is actually getting into the mountains and learning about weather, learning about energy use. And I think everybody that's been involved in this training process has been really impressed with how much hard work and dedication he's put into it and how fast he actually learned.
So we're here in China for 16 days at this amazing location to shoot Jetman. They're going to be doing stunts all around the mountain, and I'm optimistic that over the next 16 days that we're going to get some great stuff.
We are very lucky to be able to come and fly here. It's just going to be crazy to be flying with Vince in this place. The approach that we are going to go through the hole, it's already going to be insane because we are going to go literally like on top of all this. Yeah. In between those two peaks. Well, to come, you know, from there, make a kind of a hover there.
We're here in China to practice a very important milestone, which is basically we're trying to see if we can fly through a very narrow obstacle, which is very important in flight in general. Fly around and then hover mid-air to see if they can stop mid-air and stay there for a bit and then continue their flight. So China is a very important milestone.
such a big teamwork. You know, once again, it's the two of us flying, but you know, the engineer, they are doing like the behind the scene job, man. You should see the amount of work that Rashid and all those guys they are doing. It's crazy, man.
So the reason we're doing this today is because we always believed that the UAE is a nation of no limits. It is a nation that also celebrates human achievements and innovation. And Expo 2020 is the perfect stage to tell that inspiring story. An innovation with a purpose, through its sub-theme of mobility. And we wanted to celebrate the relationship between human beings and technology.
اسمي أحمد الشحي، أول طائر بشري إماراتي بالتعاون مع جتمان دبي وإكس دبي وإكسبو 2020. سنقوم بتقديم أول مشروع طيران بشري مستقل 100% في إكسبو 2020، حيث يقوم فريق الجتمان 4 مناورات في تقريبا شتى أنحاء العالم. سنة 2011 بديت كهاوي في سكاي دايف دبي، والحمد لله بعد سنة تم اختياري أن أكون أحد أعضاء منتخب دولة الإمارات العربية المتحدة وأمثل دولتي في كثير من البطولات الخارجية والمشاركات في داخل الدولة وخارج الدولة، وتمثيلها خير تمثيل. في سنة 2019 تم اختياري لأكون أول طائر بشري إماراتي. المحطة الأهم بالنسبة لي أنا الطيران المستقل، أني أطير طيران مستقل من الأرض وأرد أنزل مرة ثانية من بعد ما أتدرب التدريبات اللي وضعها لي فريق الجتمان وإكس دبي بالتعاون مع إكسبو 2020 ومتابعتهم البرنامج. هاي بتكون الأهم لحظة لي أنا. المدة راح تكون تقريبا من 1.5 سنة إلى 2 سنين. طبعا الصعوبات التي تواجهنا في هذا المشروع أن نكون متحملين المسؤولية، بس الحمد لله فريق جتمان دبي وإكس دبي وإكسبو 2020 اختاروا لي أفضل مدربين في العالم ورسموا لي المسار الصحيح لاختيار المدربين، في اختيار البرنامج، في اختيار الناس اللي هم يوجهوني لخوض هذه التجارب. طبعا دور إكسبو دور كبير جدا بالنسبة لنا نحن كمشروع الطيران البشري، لأن إكسبو منصة جدا 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 كبيرة انك تعرض فيها مشروع مثل هالمشاريع هاي، مثل تعزيز المواصلات والنقل وهالامور هاي. فنحن راح نعرض مشروع الطيران البشري اللي راح يعزز المواصلات الجوية في المستقبل إن شاء الله. دعم إكسبو لي أنا كتدريب واستثمارهم لي في مشروع الطيران البشري دعم كبير، وفي تسهيل عمليات الطيران خارج الدولة من ضمن العلاقات اللي تحكمهم مع العالم. الحمد لله دولة الإمارات العربية المتحدة وفرت لنا وحكومتها وفرت لنا كل وسائل التدريب، مثل ما احنا شايفين احنا حاليا في مقر الجتمان في دبي موفرين لك كل المعدات، الطائرات، منصات الطيران المستقل حاطينها خارج المستودع. فالحمد لله المكان جدا مهيئ لهالاوضاع هذه، مثل ما استثمرت دولة الإمارات العربية المتحدة في الشباب اللي سووا مسبار الأمل اللي هو الحين في اتجاه المريخ. طبعا هذه النظرة أنا أشوفها نفس النظرة بالضبط، ومتأملين أنه بتكون في مدرسة في مدينة دبي، فالجماعة ياسين يهيئون إعمارهم لهالشيء، والحمد لله من فضل قراءة الياسين نشوفها أن الناس متحمسين لهالموضوع. ستكون هناك خطوة كبيرة في تعزيز المواصلات والنقل.